Okay, hi everyone. We are working on 2.2 today, which is arithmetic combinations of functions. I feel like I say this about everything, but I think this is going to feel like a review to you and hopefully will look familiar. So just moving on, again, just a reminder that this is chapter 2, which is based on transformations. And today's stuff is also going back to grade 10 as the first time that you learn this. So let's start off with a little bit of review. You first learned how to do linear equations actually long before grade 10, probably grade 8 and 9, or 9 for the first time. So these are both, or no, the first one is a linear equation, y equals 2x plus 3. And you learned how to write this in function notation by basically, instead of y, replacing it with f of x equals 2x plus 3. Everything else is exactly the same. We just recognize that y can be written, I guess, with a little more detail as f of x, where y is a function of x, or it depends on what we plug in for x, is ultimately what that's saying. So since I used f of x for this first equation here that I've checked off, then maybe the next one here, instead of f of x, I could use any letter I want, but I'm going to call it g of x, just so that if I start to combine these, I can differentiate between the two. And everything else is the same, x squared minus 4, which you know would be a parabola. That has been shifted down 4 spots because of that minus 4, which actually is a transformation. So you've done transformations before last year, but you just didn't know that that's what they were called. So we're going to do more of them this year. So, having said that, let's move on to looking for the sum of these functions. So it's asking for f plus g of x. So this is, well, I was going to say this is new, but I don't think it is. I think you did this in grade 10. But maybe you need a refresher. This is saying f of x plus what we had for g of x. And so as we go through and fill this in, we know that our f of x, if I were to go back, was 2x plus 3. So I simply plug in here 2x plus 3 plus our g of x, if we go back here, was x squared minus 4. So I'm going to say x squared minus 4. I really don't need the brackets there. I just like to do it to show you where this is coming from. And then if we can, we would look to simplify or combine some of this stuff. And we can, the only thing we can simplify or combine is the plus 3 and the minus 4. And it's probably a good idea to write it in descending order. That's how you've learned how to do this. So it would be x squared, it's positive, so I can just take it and move it to the front, plus 2x. Good habit to get into, to just keep track of what you have going on, because we're going to have lots of things going on as we move on in this course. And then we have 3 minus 4, so we end up with minus 1. And there's our end result. There's nothing else we can simplify. So f plus g of x ends up simplifying to this thing in the box. I feel like you probably don't even need the next one, but we're going to do it anyways. We're doing the same thing, but this time it's f minus g of x, and it's exactly what you would think. It would be f of x minus, and this time the brackets are kind of important because of that minus sign. And again, we're going to use the same f of x and g of x that I had written at the start. So we would have f of x was 2x plus 3. You can look at your notes if you want. I just don't want to keep scrolling back, but that's ultimately where we're getting it from, 2x plus 3, and then minus, it was x squared minus 4. Oh wow, I didn't use green, it's awful. X squared minus 4. just like that. So this is going to look like small nitpicky stuff, but we need to make sure that we distribute this minus sign to both of those. So we would have 2x plus 3 minus x squared plus 4. Same thing as what we did with the example above, and that is that we want to simplify and rearrange these to write it in appropriate format, which is usually in descending order. So just this and this can be combined, and the others I need to rearrange. So minus x squared, I'm going to move to the front, plus 2x, done, 3 plus 4, so plus 7. And these are just little habits that I think are good to get into, because I find year after year, I don't think it's necessarily that people don't know how to do the math. Oftentimes it's just you forgot a negative here, or you didn't see the plus 4 at the end, or you left something off. So if you do this little stuff like underlining the like terms and checking them off when you're done with them, little things like that, little organizational things, will allow you to not make the little mistakes that kind of hurt when you get back an assessment and see that you knew how to do it, but you just made a little mistake. So those are things to watch for. And then moving on to product, we can see that if you have f and g of x, it's going to be f of x times g of x, but we're still using the same function. So we have 2x plus 3, and our g of x, so we're going to multiply by x squared minus 4. So we are foiling this puppy out. So 2x times x squared would be 2x cubed, and then 2x times this is going to be minus 8x, and then I'm going to move on to this and say plus 3x squared, and then minus 12. I check to see if there's anything at all that I can combine. Doesn't look like there's any like terms, and then I get into the habit of writing it in descending order, so plus 3x squared minus 8x minus 12, and good a habit to have to put a box or a circle around your final end result. I would like for you to also do this to make things super clear, neat, and organized for whoever is marking your work. It might be me, it might be somebody else next year, but these are good habits to get yourselves into. Okay, next comes quotient. So with our quotient, we're still using the same functions here. So f over g of x is f of x over g of x, and our f of x was 2x plus 3. And our g of x, I'm color coding them so that you can keep track of all of this and remember what everything is. And if you don't already do so, it might be a good idea to get different colored pens or something to sort of mimic what I do, because again, I actually do it for a specific purpose, and that is to keep things super neat, clear, and organized, because I honestly think that, I think for school in general, actually maybe life in general, keeping organized really helps to eliminate so many of the mistakes and the confusion and the things that come up that don't allow you to be successful. So if you're not already doing this, it might be a good idea to get the different colors. It's not just to make it look pretty, it's so that you can really clearly see what you're working with. And I feel like I can use the colors to sort of highlight specific steps to make it super clear for you. So if that system works for you, go for it and use it. When I look at this, our hope is always to simplify things as much as we can. We know at the bottom that's a difference of squares, so we could do x plus 2, x minus 2, but that doesn't help to cancel out the top. So that's how we're going to leave that. And then we're going to move on. When two functions, f of x and g of x, are added, subtracted, multiplied, or divided, the domain of the new function is the set of values of x that are common to the domain of f of x and g of x. Okay, that probably didn't make any sense, so let's use an example to clear that up. So, let me try to rephrase that, realizing that's not the neatest looking thing either, but we're going to try to work with it. So, all this is saying is when you are bringing two different functions together, you need to consider what the new domain is going to be. You have to look at the original functions in order to consider the end result. So let's take a look at how this could possibly show up. Okay, so if we have f of x is 2x plus 3, and k of x is x squared minus 2x plus 1, find fk of 3. Okay, so first of all, we know that this would be the same thing as writing f of 3 times k of 3. That's the first step. So our way of dealing with that, you know what? How could I not color coordinate this? Sorry guys. K of 3. So if I want to look at f of 3, I just go back to this. This is the stuff that's sort of referring back to grade 10 stuff that you learned. And that is that you simply take the 3 and replace the x with the 3. So I would say 2 times 3 plus 3. And I would multiply that by 3 squared minus 2 times 3 plus 1. Working our way through this, 3 times 2 is 6, plus 3, we get 9. And on the other side here, we would get we would get 4, right? So this would be 9 minus 6 plus 1. And so we get 36. Okay, moving on. I'm starting to lose my voice. Pardon me. Okay, we're going to do the same type of thing here, but I'm wondering why I didn't leave myself any space to do this. So we're going to create space. I'm going to move this out of the way. And there we go, much better. Okay, so we have f of 1 times k of 1 minus h of 2. I'm going to put a big bracket there. H of 2 times g of 2. So let's work our way through this. F of 1, I'm going to get from over here. So f of 1 would be, I'm going to put it in brackets, I'm going to leave myself some space. It's going to be 2 times 1 plus 1. Times, when I look at k of 1, well, look over here. K of x is equal to 2. So if I plug in a 1 there, it doesn't matter. I could plug in anything. The answer is going to be 2. So this is just multiplying it by the number 2. Minus h of 2. Okay, when I look at h of x, it's x cubed. So it's going to be 2 cubed times, then I look at g of 2, and I can see g of x is all of this thing. So I'm just plugging in a 2 into all the x's. So 2 squared minus 2 times 2 plus 1. I know, this is a lot of things happening. So at this point, if you need to pause to check to see that you know where everything came from, go for it. I'm hoping my color coding is helping you to find some clarity. Okay, so then working our way through this, do you see we would just get 2 times 1 is 2 plus 1 is 3 times 2, so we just get a 6 here, minus, we'll do this step by step, so that's just going to give us our 8, and just so that you can see super clearly where this is all coming from, we're multiplying that. If you look here, that's going to be 4 minus 4, so it actually cancels out, so I'm actually just multiplying it by 1. And so when I go through and simplify all of this, I'm really just doing 6 minus 8. So after all that, it works out to be negative 2. So I could say f of k of 1 minus h of g of 2 equals negative 2. But then here's all the stuff that we did to get us there. Okay, on to the last example. Given f of x and g of x, graph f minus g of x. So here are the graphs. Given f of x and g of x, graph f minus g of x. So I like to go through this to help you to understand where this is coming from. I'm going to teach you some strategies for how to do this. So for example, if I want to come up with this, we'll do it in pink, this f minus g of x. Ultimately, what we're doing is f of x minus g of x. I'm going to call the black one here f of x, and I'm going to call the blue one here, oh, I guess it already says it here. Never mind. I'm just going to put an x there, and I'm going to put an x there so you can see where it's coming from. But they're already labeled. The top one or the black one is f, the blue one is g. So here's a strategy to do this. Here's the easiest way to do this. This is what it's ultimately saying. So all that it's really wanting us to do is to subtract the y values, because this f of x is basically asking what are the y values of the f function minus the y values of the g function. So one approach or one strategy to do this is to look at this. My y value there is 8, and my y value here is 3. So I'm just going to show you an example. For this first point here, I'm just doing 8 minus 3, which is 5. So I'm going to put an x there to show you that is actually a point on our new graph, f of x minus g of x. I could do the same thing here. Here's my point at 5. Here's another one at 3. So when I do f of x minus g of x, it would be 5 minus 3, which is 2. So my new point is down here. I could also do this here. There's my y value of 7. Here's my y value at 3. 7 minus 3 is 4. So there's my new y value there. I could do that here. 6 minus 3. So it would be at 3. So you're kind of getting the idea of how we're coming up with this. What I'm trying to do is choose values that are right at the corner, right at whole numbers. So there is a y value of 6 minus 4, and that's going to leave me at 2. Okay, so you're starting to get a sense of what we are working with here. Here we have a y value of 6 and a y value of 2. So if I have 6 minus 2, that leaves me with 4, which is up here. Here my y value is at 10, and here my y value is at 1. So 10 minus 1 leaves me at 9. So my point would be up here. So when I go to put these together, I start to get a sense of what my new graph would look like. So we can see the trend here, we can see the trend here, and we can see it up to there. And even though it's not at a whole number, we might want to do one here just to get a sense of where it would go or to double check. So here I have a y value of 7, and let's say here it's at 3.5. Well, if we subtract those, it actually ends up at the same spot, so it's following a pattern like this. So I'm hoping you get the idea of how to do this. If we look here, again, we're just estimating because we don't have the precise values, but you can see that the y value of the blue and the black graph is exactly the same. So it doesn't matter what the number is. Let's say it's 4.5. I do 4.5 minus 4.5. Clearly it's going to be at 0. So that tells me at this point it's going to go down to 0. So again, we're getting an idea of what this looks like. And over here, it looks like it's at about 5.5, and this is at 3. So if I have 5, but also remember that this is reversed at this point. So if we're doing f of x minus g of x, I'm going to write this one out. This would actually be 3. This is 3. It's going to be 3 minus 5.5. So that's actually at negative 2.5. So this would be headed downwards in this direction. Okay, so I hope that this gives you somewhat of an idea of how to approach a graphing question that's relating to this. Here is your assignment for the day, and that's it for 2.2.